All right, so let's talk about machine learning. This is artificial intelligence, and it is pretty easy to do rudimentary artificial intelligence with Python, which I was quite happy to find out about because I thought it would take very powerful machines and be beyond understanding. But it's not true. You can do simple things. You just have to install a bunch of libraries that are out there, and then you just need to understand what you're doing. Now, this is a famous flower data set from like the 20s or 30s. This guy just measured a bunch of numbers. It looks like this. It's just a bunch of numbers measuring plants, irises, and then putting them in categories. And all machine learning is what I used to do decades ago. It's old-fashioned science, like science from the 1800s when they were just developing electronics. You have some kind of measurement, and then you just try fitting curves to it. And then you can predict it to some extent if you find a curve that fits pretty well. So once you've installed the right libraries, this will do the importing of the data. So let's make ml1.py and put in that code. And what this code does is it connects right to GitHub and downloads the data about these flowers. And then it just prints out information about the data so we can see it. So let's run that one. Okay, so it takes a few seconds to connect to the server, and it downloads the data. And here is the 150 records and 5 fields in each record. Here's the headers, length and width of the sepal, whatever part of that is part of a flower, and length and width of the petal, and then the class. And there's 3 different kinds of irises here. The first, this is the head, the first 20 records, which are all this kind of iris. And later on, there's some other kinds of irises. So here is the average and standard deviation and such of these various parts of the flower. And here's the 3 classes. We have 50 measurements for 50 different flowers of each of these 3 categories. And the point of this is just if you have any kind of data which has some kind of pattern, machine learning is where the computer learns how to predict values from that. So here we're going to try and predict the class of a flower from these other measurements. And the point is this extends to, for example, driving a car. If you have a machine learning device trying to drive a car, it has a camera and it has a LiDAR system and it has other inputs that are just numbers. And it has to decide from those numbers whether to hit the brake or step on the gas or turn right or turn left, things like that. And that's what it does. It takes all that data and just tries to find a pattern. So you have to train it on some cases where you can tell it whether it was right or wrong. And it learns to be right more often and then acts based on that data. So we're going to visualize the data with histograms. Here's the one that does that. All right. And so if I run that one, that will create a visual representation. It will launch some other program which draws these graphs. And now you can see that the petal length, for example, has a peak at small values and another peak at high values. So it looks, for example, like petal length is probably going to be a pretty good indicator. This might be one category and that might be the others. And here's another thing, petal width seems to have 2 groupings, but these combinations of numbers could perhaps be used to predict it. So for that, we want to do multivariate plots, which looks like this. So if you run that one, it's going to launch that graphical view. And now you're going to see correlations. So this is sepal length against sepal length. The ones on the diagonal are the same ones we saw before, just showing the distribution of these measurements. And here's the correlation. And so here you can see that petal width is connected with petal length. The petals that are wider are also longer. So it goes like this. This is a strong correlation. But here's something that has something very different than a correlation, like separate groups. And those are probably the categories. So far, you're just seeing the input data. But now, this is the part that does machine learning. After you import the data, you split it out. You tell it with the X array and the Y array what it's trying to predict from the other data, and then you split it with this stuff into 10 splits, each containing 1/10 of the data. It trains on 9/10 of the data, and then it tests it by trying to predict the last 1/10 of the data. That's what all this garbage does. And right now, you're probably just copying and pasting stuff with only a minimal understanding of what it's doing. But after this, you get to like make your own version for other kinds of data and get some practice in understanding how to set this up. So if you run this one, it runs, and what you're seeing here is the rate of success. And there are different models. There's like 5 or 6 different models you tried here, and you can see this is the accuracy, and this is the standard deviation of the accuracy. So the most accurate thing here was this SVM model. The LDA model was pretty close, and the others were much less successful at predicting the data. So this is how it looks on the scale support vector machines. So there's a couple challenges here. I tried to predict some COVID data, but I wasn't really able to make anything that made a lot of sense, but I was able to get some data and import it and do some of this. And then I went to a more standard one, which is a standard one in machine learning tutorials, abalone data, which is very similar. You measure all these things about abalones, they shucked them and measured how much they weighed and how much the shell weighed and stuff like that. And then you can try to predict whether they're male or female. So you can do some more training on this abalone data. And that's very basic machine learning, but it gets you started with just simple Python. It doesn't require a lot of memory or a fast computer or anything. The basics can be done very simply with Python.